asked to compute the moment about point O. So here in our given information, we're going to have this cantilever system. So we have this kind of inverted L shape, and here we have a force of 100 newtons being applied, and this is at a 4-3 slope, and this vertical piece of this cantilever system is 2 meters long, and the horizontal piece of this cantilever system is 5 meters long, and then we have our point O at the fixed connection on the left. So to get started on this, first you want to notice that the applied force is at an angle. It's not vertical or horizontal, it's at an angle. So what we need to do is, I'm going to redraw this system. Try to draw a better line. There we go. And what we need to do is resolve the force into horizontal and vertical components. Okay, so yes, we have this 100 newtons here, but this can be resolved into a vertical component and a horizontal component for sure. And that's again based on our slope angles, or our slope ratios. It's a 3-4-5, makes a 3-4-5 ratio slope. So I'm gonna call the horizontal piece little fx. I'm gonna call the vertical piece little fy. And don't forget our dimension lines that we have here, 2 meters and 5 meters. So what's happening at point O is we're getting a tendency of rotation, but it's broken down based on the tendency of rotation caused by the vertical component of the force and also caused by the horizontal component. So in a situation like this, what we have to do is look at the tendency of rotation about point O due to each of these components separately, and then we need to add their effects. Okay, so let's make a note of that. We need to investigate the tendency of rotation due to each force component individually, and then add their effects. Okay, so let's look at the x component of this force first. All right, we have this x component, and it's at a perpendicular distance of what? Is it 5 meters or 2 meters? Pause the video, think about it. The x component is at a 2 meter perpendicular distance away from point O. We can kind of see that right here, all right? And so let's look at that. Let's say that the moment, counterclockwise positive, about point O. Let's look at that x component first. It's going to be f sub x times 2 meters, okay? How do I know that's a positive quantity? Well, forget about the y component for now. Let's just think about x. This x component is causing a counterclockwise tendency of rotation about point O, and counterclockwise tendencies of rotation are positive, all right? Now what about the y component? For now we're going to forget about x and put our attention on this y component of the force, f sub y. So what is its perpendicular distance away from point O? Well, that's the 5 meters for sure. Again, it's the distance, perpendicular distance is the distance from the line of action of the force to the point of interest. That's why we say perpendicular distance, okay? So the tendency of rotation caused by the y component, what direction is that going to be? Well, that's going to be a clockwise tendency of rotation. So in that case, we're going to call that a negative quantity. So we're going to say minus F sub y times 5 meters, okay? Now, the question is, how do you get Fx and Fy? Well, of course, F sub x is going to be 100 newtons times 4/5, which is going to be 80 newtons. And then the y component is, of course, 100 newtons times 3/5, which is 60 newtons. So substituting these values in, we're going to have the moment about point O is 80 newtons times 2 meters minus 60 newtons times 5 meters. And substituting those values in and punching this in your calculator, maybe you could even do this in your head, maybe punch this through in your head as well, you should get negative 140 Newton meters, okay? Negative 140 Newton meters. So what does this negative sign indicate? Well, remember, negative indicates a net clockwise rotation, okay? A net clockwise rotation. So what we could end up saying is the moment about point O is 140 Newton meters, and draw a little clockwise symbol and omit the negative there, all right? So again, make sure you're paying attention to the sign convention for these types of problems.